It's your girl scientist Nicole Wayne Unson, and you are watching I Can Science You! Episode 13, entitled Experiment 4, Abracadabra, Shake It Blue. On today's experiment, we need a clear bottle with cup, distilled water, sodium hydroxide, dextrose, and methylene blue. So what are we waiting for? Let's get into it! The first step is to add 150 ml of distilled water into the clear bottle. Then, add 5 grams of sodium hydroxide. Stir until the solid is dissolved. Add 7 grams of dextrose and 12 grams of methylene blue indicator solution. Cup the clear bottle and mix thoroughly by swirling it a little. Now, shake the bottle, wait for a little while, and see what happens. Wow! Did you notice that? Amazing, right? The moment we shake the bottle, we can see that it obtained a blue color. However, as we wait patiently, the blue color starts to fade and the solution turns colorless again. And we notice that there's a time required for the blue color to disappear. Amazing, right? But how does this experiment works? Actually, the rate of the reaction can be determined by measuring the concentration of reactants or products as a function of time. So, in this experiment, methylene blue exists in two forms, a reduced form and an oxidized form that have different colors. The color change results from the reversible oxidation-reduction reaction of the methylene blue indicator. The reduced form is colorless and the oxidized form is color blue. The reduced form can be converted to the oxidized form by simply shaking. Shaking the solution raises the concentration of oxygen and the mixture and oxidizes the methylene blue back to its blue form. However, the oxidized form can be converted back to the reduced form by treatment with its reducing sugar or reducing agent, which is the dextrose. We stop introducing the oxygen in the solution, which dextrose and potassium hydroxide give the indicator colorless. Upper layer remains a little bit blue because it stays in contact with the air. The time needed for the solution to turn colorless can then be measured and used to determine the rate of reaction and the effects of concentration and temperature on the rate. The experiment was repeated with various concentration of methylene blue indicator, dextrose, and sodium hydroxide concentration. It was observed that regeneration of color and color loss is the best visual example of explanation of equilibrium. I hope you enjoyed and learned a lot. Bye!